Good evening students, I welcome you all to the video lecture of bit error rate for the modulation schemes. As in the earlier lectures, we have discussed different modulation scheme for a single users, for various multiple user. We have discussed PAM, PPM, on-off keying, and then we have used multiple SS schemes where we have discussed DS and TH schemes. Now it is the time for the bit error rate of modulation schemes. So what do you mean by the term bit error rate? So when we talk about the term bit error rate, it is defined as number of bit errors per unit time. That is number of bit errors divided by total bits transferred. Now again, if we want to analyze bit error rate, we can use a specific model. So here in this case, we are using a AWGN model. What is AWGN model? It is additive wide Gaussian noise model. So when we talk about additive wide Gaussian noise model, what does it mean? It means that a noise is intrinsic to system and it is additive in nature. It is wide. When we talk about wide, it means that there is uniform noise across the frequency spectrum. And then we say that it is Gaussian in shape. So for a noisy channel, AWGN system, when we talk about BER, it is expressed in as a function of EB by NO. What is EB by NO? EB by NO is the ratio of energy per bit to the noise power spectral density. So now we talk about BER for the different modulation scheme. So for a multiple user MRE PAM modulation scheme, the symbol error rate probability is defined as PS, and there is a graph which is being plotted between PS and EB and NO. So from the graph it can be seen that there is a relation between PS and EB and NO depending upon M array user, that is 2, 4, 18, 16 and 32. So this graph varies as we increase the value from 2 to 4, 4 to 8, 8 to 16 and 16 to 32. So there is a variation between symbol error probability, that is PS, and EB by NO, which is measured in decibels. So if we talk about, so this is about PAM system. So if we talk about PS system, the value of PS is calculated by this equation. That is, it is calculated by this equation, which is equal to PS is equal to 2 into 1 minus 1 by M Q times this portion. If we use gray mapping technique that we use for various modulation scheme, then P bit will be equal to 1 log to the 2 log to the base 2 M PS. So taking these two equations, we will get the value of P bit, which is equal to 2 divided by log to the base 2M log to the base 2M into this equation. So from this equation, we can plot the bit error rate graph for PAM system. Now similarly, for a PPM system, we can use upper bound and lower bound. So for the upper bound, we take EB by NO is greater than 4 log 2, and for the other bound, that is EB by NO is less than 4 log to the base 2. So by taking this value and taking other bounds into consideration, that is EB by NO greater than 4 log 2 and EB by NO is less than 4 log 2, by taking all these value into consideration, we can plot this graph between P bit and EB by NO, which is measured in decibel. Again, we can easily visualize from this graph that there is variation of probability bit for a error with respect to EB by NO if we increase the value from 2 to 4, 4 to 8, 8 to 16, 16 to 34 and 34 to 32 to 16 to 32 and from 32 to 64. So this is all about bit error rate using AWGN, that is additive wide Gaussian noise model. I hope you will like this lecture. Thank you very much for listening. Thank you very much.